So we are continuing with more examples on groups of trigonometric identities. So the first one goes, prove that sec squared theta plus cosec squared theta equals sec squared theta cosec squared theta. So what do we do with this? The left hand side is containing sec squared theta plus cosec squared theta. We want to see if that the addition is bringing the product of them. So what we do here is we go back, ask ourselves, a sec squared is the same as what? A sec squared is the same as 1 out of cos squared theta plus, what about a cosec squared? A cosec squared came from 1 over sine squared. We say 1 out of sine squared theta. As we did in the previous videos, as we're trying to look at that. So, can we go ahead and look for the LCM? What is the LCM? The LCM of cos squared and sine squared remains as cos squared theta, sine squared theta. Cos squared theta, sine squared theta, divided by cos squared. Automatically you get a sine squared. The sine squared times 1, you are getting a sine squared theta plus cos squared theta, sine squared theta, divided by sine squared. But we are going to remain with the cos squared. Times 1, we are getting the cos squared theta. But recall yesterday, cosine squared plus cos squared gives us 1. So instead of this, we are going to automatically write 1 out of cos squared theta sine squared theta. What is happening with this? The division goes on every number. This is the same as 1 out of cos squared theta times 1 out of sine squared theta. Then we ask ourselves again, 1 over cos squared, you're getting what we call the sec squared theta. 1 over sine squared, you're getting what we call cosec squared theta. Hence, proved. This is what they requested you to do, which was sec squared theta plus cosec squared theta. You are coming out with this. This is how we can prove such kind of trigonometric identities. So we are going to go to proof number 2, which goes, prove that cot power 4 theta plus cot squared theta equals cosec power 4 theta minus cosec squared theta. So, they have said that we prove that the left hand side is containing cot power 4 theta plus a cot squared theta equals cosec power 4 theta minus cosec squared. What do we do with such kind of a number like that? What we do here, we are going to consider the left hand side. We are moving to our solution. Cot power 4 theta plus cot squared theta is the same as, by mere seeing, what is common here? What is common is a cot squared. You can see it is here and there. So we are going to pull out a cot squared theta into, I'm going to remain with cot squared theta plus 1. We're going to remain with cot squared theta plus 1. But recall that from the identity which we proved, that 1 plus a cot squared theta, 1 plus a cot squared theta, we are getting what we call a cosec squared theta. Now, if I make cot squared theta the subject, what is going to happen? When I make cot squared theta the subject, cot squared theta is the same as cosec squared theta minus 1. Now, where I see 1 plus cot squared, I'm going to put cosec squared theta. And where I see a cot squared, I'm going to put cosec squared theta minus 1. Then we go back to our expression. Cot power 4 theta plus cot squared theta equals, where there is a cot squared theta, I'm going to put cosec squared d. I'm going to put cosec squared theta minus 1. We go. This is cosec squared theta minus 1 into, where you see a cot squared theta plus 1, I'm going to put a cosec squared theta. I put cosec squared theta. So from there, we are free to open the brackets. We insert in the cosec squared. Cosec squared theta times cosec squared theta, I'm getting cosec over 4 theta minus cosec squared theta times 1, we're getting a cosec squared theta, which has come, as I've said, hence probability. So this is what we can do with as far as proofs are concerned.